Good afternoon everyone. This is the first chapter of physics, electric charges and fields. So let's start with this. First topic is electric charges. Electric charges means what? Electric charges are the positive and negative charges in an electromagnetic field that is called as electric charges. Electric charge is a characteristic that accompanies fundamental particles wherever they exist. Fundamental particle means we have the electromagnetic field and we have plus and minus, positive and negative charges. These are the electric charges. So this is the characteristics that accompanies fundamental particles, that all are based on the particle basis. On the basis of particles, that positive and negative charges are depend. So according to the William Gilbert, charge is something possessed by material objects that makes it possible for them to exert electric force and respond to the electrical force. So according to the William Gilbert, charge is something possessed by material object. Whatever material object we have, according to that the charges are depends. So that makes it possible for them to exert electrical force. So that depends on the electrical force, and according to that electrical force will respond to that particular material object. So it is a scalar quantity basically. So next is what? This is the example of gold leaf electroscope. So we have that particular, look at this object, we have that particular gold leaf electroscope. So we have glass window over here, we have that gold leaves, we have metal knob and metal rod. So over here we can see there are positive charges over there. So this is the gold leaves, we have positive charges. This is the rod, we have knob, we have positive charges, and that rod also have positive charges. Okay, so it is one of the instruments, and according to the electrostatic force, we have electric charges on that. Okay, so when a charge is applied to the plate to which the rod is connected, when we are applying the charges to the plate, okay, to which the rod is connected, we are applying the charges. This is your leaf, that is plate, and we are applying it to the according to the rod. This is rod and this is knob. Okay, so the leaves separate due to their mutual repulsion. That leaves separate due to their mutual repulsion. Okay, one variation involves having one fixed plate along with the single leaf. Okay, we have single leaf, this is, we can see over here, this is a single leaf, this is another leaf, and we have positive charge over it. So according to the metal rod and metal knob, we are providing the charges on that particular plate of gold leaf. Okay, and this is your glass window. Okay, next there are two kinds of charges such as positive charge and negative charge. So we have positive charges on the object by losing electrons, while other can attain negative charge by gaining electron. Okay, if we have positive charge, we have to lose the electrons, and if we have negative charge, we are gaining the electrons. Charges with same sign, that is like charges repel each other, while charges with opposite sign, that is unlike charges, attract each other. Charges with the same sign, if we have same sign, that is like charges repel each other. Okay, and if we have opposite sign, that unlike charges attract each other. Okay, means positive and negative charges we have, then that will be attracting each other. And if we have same sign, that charges repel with each other. Then charges always reside on the surface of the charge conducting object. Charges always reside on the surface. Charges always reside on the surface. सरफेस के ऊपर जो भी हमारे पास चार्जेस होंगे, that charges are conducting on object, and object can be charged by different methods. जो भी ऑब्जेक्ट हमारे पास चार्जेस रहेंगे, that is opposite, or we can say that is positive or negative charge. by losing or gaining the electrons. That all are depends on the different methods like friction, conduction and induction. Then charges can be added and subtracted as a number. वो चार्जेस जो भी रहेंगे वो हम ऐड भी कर सकते हैं या सब्ट्रैक्ट भी कर सकते हैं एज अ नंबर. ओके, दैट बेसिस ऑन द मेटल्स, जो भी मेटल्स जो भी ऑब्जेक्ट रहेंगे मेरे पास फॉर द कंडक्शन एंड इंडक्शन, ओके, और फॉर द फ्रिक्शन. देन कंडक्टर्स एंड इंसुलेटर्स. Conductors are those substances which can be used to carry or conduct electric charge or electron from one point to the another. कंडक्टर्स और इंसुलेटर्स में हम लोग क्या कहेंगे कि कंडक्टर्स जो भी रहेंगे हमारे पास, those conductors are substances which can be used to carry or conduct the electric charge or electron from one point to the another. For example, in that particular gold lip electron we have different points for the different charges. So we are carrying or conducting the electron charge or electron from one point to the another. They allow electricity to pass through them easily. We are passing the electrons through them easily. For example, silver, copper, iron, aluminum, etc. Then insulators are those substances which cannot conduct electricity. जो इलेक्ट्रिसिटी कंडक्ट नहीं करता है उसको हम इंसुलेटर्स बोलते हैं. ओके, सो दे आर व्हाट? डाइलेक्ट्रिक्स. They offer high resistance to the passage of electricity through them. What we are doing, we are offering the high resistance to the passage of electricity through them. Okay, for example, glass, rubber, plastic, ebonite, mica, these are the examples of insulators, and silver, copper, iron, aluminum, these are the example of conductors. Okay, then difference between dielectrics and conductors. Dielectrics are non-conductors and do not have free electrons at all. Okay, means non-conductors means what? Insulators. They are what? Insulators, and they do not have free electrons at all. While conductors have free electrons in their any volume which makes them able to pass the electricity through them, right? And conductors have the free electrons and they can pass the electricity through them. Okay. So charging by the induction, we can see over here the process of charging a neutral body by bringing a charged body nearby it without making contact between two bodies is known as charging by induction. And induction means what? Inductors. So the process of charging a neutral body by bringing a charged body nearby. Okay, प्रोसेस ऑफ चार्जिंग अ न्यूट्रल बॉडी. जो भी हमारे पास बॉडी रहेगी उसको जब हम न्यूट्रल बॉडी को जब हम चार्ज करेंगे, कैसे चार्ज कर सकते हैं हमको? उसको हम बाय ब्रिंगिंग अ चार्ज बॉडी नियर बाय इट विदाउट मेकिंग कॉन्टैक्ट बिटवीन टू बॉडीज. जो बॉडीज मेरे पास रहेगी, एक न्यूट्रल बॉडी रहेगी और एक चार्ज बॉडी रहेगी, उसके बीच में कांटेक्ट नहीं रहेगा, देन दैट विल कॉल्ड एज चार्जिंग बाय इंडक्शन. एक न्यूट्रल बॉडी रहेगी जिसके ऊपर चार्ज नहीं रहेगा, वी हैव टू चार्ज दैट बॉडी, एंड वन बॉडी वी हैव दैट मेक्स विदाउट मेकिंग कॉन्टैक्ट, दैट मेक्स bringing a charged body nearby without making contact between the two bodies. Okay, is known as charging by induction. For example, this is one of the figure given below that showing the sequential steps of charging a conductor permanently by using the process of charging by induction. जैसे using the process of charging by induction, a conductor may be charged permanently. Okay, जैसे यहाँ पे एक बॉडी मेरे पास कौन सी है? न्यूट्रल बॉडी है, और एक बॉडी है मेरे पास चार्ज बॉडी है, पॉजिटिव एंड नेगेटिव चार्ज. और जो भी मेरे पास फिगर 3 रहेगा जिसके ऊपर हमारी एक न्यूट्रल बॉडी रहेगी और एक चार्ज बॉडी रहेगी, और तीसरा फिगर जो है, थर्ड फिगर, जो क्या करेगा? हमारे चार्जेस को कंबाइन करेगा. जैसे न्यूट्रल बॉडी और दूसरी बॉडी जो है हमारे पास, वो कांटेक्ट नहीं करेगी इन बिटवीन, इसलिए यहाँ पे नेगेटिव एंड पॉजिटिव चार्ज है, और यहाँ पे जो भी हमारे चार्जेस रहेंगे दैट विल बी योर फ्यूजन ऑफ योर नेक्स्ट बॉडी. जो भी बॉडी हमारे पास रहेगी वो एक चार्ज पॉजिटिव लेगी और जो भी रॉड रहेगा वो नेगेटिव का रहेगा, एंड दैट विल बी योर इलेक्ट्रॉन्स. that will be your negative or positive, we can say that is the without making the contact between the two bodies is called as charging by induction. Okay, induction means what? Electrons that contains positive and negative charges. तो यहाँ पे जो negative charges body B में आपको दिख रहे हैं, वो यहाँ पे हमारा एक फ्यूजन करके एक कंबाइंड मेटल बन रहा है जो पॉजिटिव एंड नेगेटिव बॉडी को कंटेन करेगा. ओके, then example 1, a comb run through one's hair attracts small beads of paper. What happens if the hairs are wet or it is a rainy day? Okay, क्या होगा तब? solution क्या है? If the hairs are wet or it is a rainy day, then the friction between the hair and the comb reduces, right? friction हो जाएगा, वो friction reduce हो जाएगा क्योंकि वो rainy day में it will be a moisture over there. So the comb does not get charge and it will not attract small beads of paper. जो comb रहेगा वो charge नहीं होगा और इसके कारण क्या होगा? It will not attract small beads of paper. पेपर को attract नहीं कर पाएगा. So that is only over here. That is charging by induction. जैसे यहाँ पे मैंने आपको बताया कि फिगर जो मेरे पास एक है, वन फिगर जो न्यूट्रल बॉडी है और ये मेरी चार्ज बॉडी है, तो ये जो फ्यूजन होगा मेरे पास वो पॉजिटिव का होगा और जो भी मेरे पास जो ये फ्यूजन होगा दैट विल बी योर नेक्स्ट बॉडी दैट इज नॉट न्यूट्रल, दैट इज द कंबाइंड चार्ज. ओके, ऑफ नेगेटिव एंड पॉजिटिव. ओके, पॉजिटिव चार्ज जो है वो यहाँ पे रहेंगे लेकिन नेगेटिव चार्ज रहेगा उसका हम लोग क्या मिला, उसका हमको क्या मिलेगा? एक नॉर्मल और नॉर्मल फ्यूजन होने के बाद जो भी हमको मिलेगा बॉडी दैट विल बी योर रिडक्शन ऑफ योर चार्ज. ओके, रिडक्शन ऑफ चार्ज. Then basic properties of electric charges. Some basic properties of electric charge are discussed below. Additive nature of electric charge. Electric charge is additive in nature. मतलब electric charge जो हमारा रहेगा, for example वो additive in nature रहेगा, so that will be your what? Positive charges. That is Q1 plus Q2 plus Q3 plus Qn. Okay, so in order to calculate the net charge on a system, we have to just add algebraically all the charges present in the system. This is known as the principle of superposition of charge. Okay, उसको हम क्या बोलेंगे? पॉजिटिव चार्ज रहेगा तो प्रिंसिपल ऑफ सुपरपोजिशन ऑफ चार्ज बोलेंगे. इफ द साइजेस ऑफ चार्ज bodies are very small as compared to distance between them, then they can be considered as point charges. Okay, if the size of charge bodies are very small, अगर स्मॉल साइज होगी हमारे बॉडी चार्ज की एज कम्पेयर टू द डिस्टेंस बिटवीन देम, उसका जो डिस्टेंस हम कैलकुलेट कर रहे हैं यहाँ पे टोटल चार्ज, सो दे कैन बी कंसिडर्ड एज पॉइंट चार्जेस, जिसको हम क्या बोलेंगे? पॉइंट चार्जेस बोलेंगे. Okay, then conservation of electric charge. During any process, the net electric charge of an isolated system remains constant. That is conserved. In simple word, charge can neither be created nor be destroyed. Okay, charge हम create भी नहीं कर सकते और destroy भी नहीं कर सकते. In any physical process, the charge may get transferred from one part of the system to the another. एक part से दूसरे part में हम transfer करेंगे हमारे charges को. As a net charge will remains the same. Net charge जो भी फाइनली आउटपुट मिलेगा हमको that will be same. वही मैंने यहाँ पे बताया आपको. ठीक है, फाइनली जो आउटपुट मिलेगा that will be your net charge. जो भी आउटपुट मिलेगा फ्यूजन के बाद, एक न्यूट्रल रहेगा बॉडी और एक चार्ज बॉडी रहेगा, so that will be your net output. Then quantization of electric charge. The charge on any body can be expressed as an integral multiple of basic unit of charge, that is charge on one electron. This phenomenon is called as quantization of electric charge. Okay, the charge on any body can be expressed as an integral multiple of basic unit of charge. Charge on any body can be expressed as an integral multiple of basic unit of charge. मतलब हमारे पास जो भी चार्जेस रहेंगे, दैट चार्ज ऑन वन इलेक्ट्रॉन, दिस फेनोमेनॉन इज कॉल्ड एज क्वांटाइजेशन ऑफ इलेक्ट्रिक चार्ज. जैसे हम लोग लिखेंगे चार्जेस ऑन व्हाट, expressed as integral multiple of basic unit of charge. Q is equals to plus minus of Ne, that is number of electrons. So N is what? Number of electrons, 1, 2, 3 is an integer, positive or negative, and E is the basic unit of charge. The SI unit of charge is called as coulomb and denoted by C. So it is the value is by default 1.60219 into 10 raised to minus 19 coulomb, or we can say 1.6 into 10 raised to minus 19 coulomb. So this is one of the example over here. We have to solve that example. So we have polythene piece rubbed with wool is found to have a negative charge of 3 into 10 raised to minus 7 coulomb. We have to find the number of electrons transfer from which to which. We have to transfer the electrons. Is there a transfer of mass from wool to polythene? That both questions we have to solve. Here is the negative charge we have on polythene piece rubbed with the wool, that is Q, minus 3 into 10 raised to minus 7 coulomb. Then we have the by default electron charge, that is minus 1.6 into 10 raised to minus 19 coulomb. Then we have to find out the number of electrons transfer from wool to polythene piece. So we have this formula over here. Wait a minute. We have this formula. Q is equals to plus minus Ne. So just we have to find out this N is equals to Q by E. We have to put the values and we are getting this answer. So yes, there is a transfer from mass from the wool to polythene piece, as mass of each electron, that is Nc is what, 9 into 10 raised to minus 31 kg. We have mass of what, each electron. Then mass transferred from wool to polythene. We have formula, total calculated mass is equals to N into mass of each electron. So we have N, 1 point, we have N over there, that is minus 1.6 into 10 raised to minus 19. We are putting the value over here, and we have Mc already given, 9 into 10 raised to minus 31 kg. So finally we are getting the output 1.687 into 10 raised to minus 18 kg. Okay, so example 3 again we have a copper slab of mass 2 gram contains 2 into 10 raised to 22 atoms. The charge on the nucleus of each atom is 29 electron. What fraction of the electrons must be removed from the sphere to give it a charge of 2 mu c? So the total number of electrons in the slab we have 29 into 2 into 10 raised to 22 atoms. Okay, this electrons we have in the slab. So the number of electrons removed, we have number of electrons, N is equals to, we are writing N over there, N is equals to Q by E. So we have Q 2 into 10 raised to minus 6. So we have 2 grams of copper slab. Okay, so we have 2 into 10 raised to minus 6. Electron we have 1.6 into 10 raised to minus 19. So we are getting over here 1.25 into 10 raised to 13. So fraction of electron removed. So we are getting over here again the answer 1.25 into 10 raised to 13, and at the bottom again we have the total number of electrons in the slab, 29 into 2 into 10 raised to 20. So finally we are getting the output 2.16 into 10 raised to minus 11. Okay, so again we have the difference between charge and mass. Charge means what, positive negative charges or zero, and mass means what, the body mass of the body is a positive quantity. Okay, and it is positive, negative or zero charge. Again, charge carried by the body does not depend upon velocity of the body. Okay, charge carried by the body does not depends upon the velocity of the body. Velocity of the body के ऊपर depend नहीं रहता है charge. जो भी velocity रहेगा हमारा, उसके ऊपर charge based नहीं होता. और यहाँ पे क्या होगा mass में, यहाँ पे हम mass of the body increases with its velocity as mass की value दी गई है यहाँ पे हमको वही मास की वैल्यू हम फाइंड आउट करेंगे, मास m0 divided by 1 minus v square by c square. So c is what? Velocity of light, 10 to 10 raised to 8 in the vacuum, and m is the mass of the body moving with velocity v, and m0 is the rest mass of the body, rest of the mass, okay, at ideal body. So we have m0 over there. Then charge is quantized, ओके चार्ज यहाँ पे क्वांटिटाइज होगा यहाँ पे, और यहाँ पे द क्वांटिटाइजेशन ऑफ मास इज येट टू बी एस्टेब्लिश. क्वांटिटाइजेशन हमको मास का बनाना पड़ेगा. ओके देन इलेक्ट्रिक चार्ज इज ऑलवेज कंजर्व्ड. इलेक्ट्रिक चार्ज यहाँ पे बनाना पड़ेगा हमको, कंजर्व्ड रहेगा, दैट इज रिजर्व्ड. एंड द मास इज नॉट कंजर्व्ड एट इट कैन बी चार्ज इनटू एनर्जी एंड वाइस वर्सा. मास जो भी रहेगा मेरे पास, that is not conserved as it can be changed into energy and vice versa. चेंज होता है मास एनर्जी में ना, और यहाँ पे इलेक्ट्रिक चार्ज जो रहेगा वो कंजर्व्ड रहेगा ऑलवेज, पॉजिटिव नेगेटिव और जीरो, और यहाँ पे चेंज होता रहेगा एनर्जी के हिसाब से. देन द चार्ज इज व्हाट? फोर्स बिटवीन चार्जेस कैन बी आइदर अट्रैक्टिव और रिपल्सिव, एज चार्जेस आर अनलाइक और लाइक चार्जेस. ओके एंड यहाँ पे the gravitational force between two masses is always attractive. यहाँ पे gravitational force जो भी रहेगा मास के बीच में, दो मास के बीच में, that always are attractive gravitational force, that is mass. okay so ये topic wise आप कुछ MCQs solve कर लेना, that I will tell you afterwards. You have that short answers also over here. okay that numerical problems also we have, you can solve it. The charges are given. okay you can solve this, otherwise I will solve these questions to you in the next lecture. okay thank you so much. So what we saw in this chapter, that is electric charges, positive negative in the electromagnetic field, that is called like electric charge, that is scalar quantity we have. Then we have the example of gold leaf electroscope. What exactly the positive and negative charges are there on gold leaf electroscope, that is electrostatic forces. okay then we have conductors and insulators. We have what are conductors or what are insulators, and difference between conductors and insulators. We have this example, charging by induction. I already taught you that we have neutral body, we have positive negative charges on next body. So finally we get the net result, that we have the positive charges and the negative charge will get into the one of the net body we get. okay that are using process of charging by induction. A conductor may be charged permanently. okay then we saw the example of hair and what? Comb. That moisture will be there in the rainy season, so the friction will not be there, so because of that it will not attract small beads of paper. okay so that is charging by induction. Then we saw basic properties of electric charges, that is positive and addition of that particular electric charges. Then conservation, that is conservation of electric charge we saw, that is conserved electric charges. Then quantization also we saw of electric charges, that is formula we saw, that is Q is equals to plus minus Ne, and we solved by default values. We saw this example, polythene piece rubbed with the wool, the negative charge of 3 into 10 raised to minus 7. After that we saw the difference between charge and mass. okay so these are the 2-3 examples I taught you of quantization of electric charge. So you can solve this topic of MCQs, and then in the next lecture I taught you the numerical problems. okay so thank you so much for this lecture.